Good afternoon. In addition to being a trained cardiovascular tissue engineer, I'm also a sci-fi aficionada. I think of science fiction as life imitating art. Remember those old science fiction movies where a badly wounded person is laid out on a gurney? They're injected with a magical elixir, a beam passes over them, and the next thing you know, they're fine. They're repaired, rejuvenated, refreshed. What if I told you that current medical technology isn't too far off from that today? Minus the beams, of course. I'm talking about the power of the stem cell. You can take a hair follicle, a blood sample, a tissue sample from under the skin, turn back the clock on those cells to create genetically identical stem cells in a dish, and then direct those cells into any cell type in the body. Heart cell, muscle cell, nerve cell. And the idea is to transplant those cells into their respective organs that are damaged or diseased. A major problem facing tissue engineers is the ability to generate highly pure as well as verifiable cell populations. You wouldn't want to transplant a muscle cell into the brain. So what about a more simplistic approach, which is generating one cell type, such as the endothelial cell, which lines blood vessels and also is responsible for producing new vessels? Oh, this is all backwards. Oh. Okay. McCloskey Lab is interested in generating highly pure endothelial cells that are able to form branch-like, tube-like formations in tissue like what you see here. In my research, I specialize in generating tip, stalk, and phalanx cells. The tip-like cells, they migrate easily through tissue, and they could be able to home to areas of damage, where the stalk-like cells proliferate quickly and should be able to replace existing vasculature, while the phalanx cells behave more like mature endothelial cells, and they should be able to pack tightly, creating an impenetrable barrier in order to line cellular therapy such as vascular grafts. Now, these cellular therapies we hope to be able to be used as a result of stroke or heart attacks, and then also disease modeling, such as cancer or atherosclerosis. Now, ladies and gentlemen, what I present to you is the future of medicine in the 21st century. And if you had ever hoped that the future of medicine will look exactly like what you see in a sci-fi movie, then don't worry, I'm working on it. Thank you.